Okay, in this video, let's see if we turn the light on if that'll be better. No, that's worse. In this video, we're going to work and learn to calculate the Pythagorean Theorem and determine the length of the sides of a right triangle. Okay? Now, first of all, the Pythagorean Theorem is a squared plus b squared equals c squared, and likewise, you could say c squared equals a squared minus b squared, or b squared minus a squared, whichever one you needed. Now, before we actually do some calculations, we're going to do just a little bit of review with perfect squares and square roots. So, if I were going to square 1, that's like saying 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, or 36. 7 squared is 49. 8 squared is 64, 9 squared is 81, and 10 squared is 100. And I can go on and on. Okay, now likewise, multiplication and division are inverse operations of each other. So squaring and taking the square root are also inverse operations. So if we were to start with this side and go back to the other, in other words, the square root of 1 tells me I want to find the two numbers exactly alike that multiply together and give me 1, which would be 1. The square root of 4 is 2 times 2. So the square root of 4 is 2, because the exact 2 times 2 are the same number that multiplied by itself that give me 4. Now, likewise, I can go backwards and do the square root of 9 is 3, square root of 16 is 4, and so forth. Now, keeping that in mind, anytime I take the square root of anything that's not 9 or 16, for example, the square root of 12, we know that the square root of 12 lies between 3 and 4, but it's irrational, it's not exact. Okay? So, let's go just one step further and let's think about reducing square roots. For example, the square root of 72. Alright? And I'm not talking about hitting the square root button on the calculator. I'm talking about giving me an exact square root in simplified form. So let's start out and let's factor this into two numbers. And I want to try to use numbers that come in this column over here so that I could take a square root of it. So I'm going to look real quick and say, we know real quickly that 9 times 8 is 72. And then I can take the square root of 9, and the square root of 9 is 3. Now, once you take the square root of that 9, it's no longer under the square root sign or the radical. It belongs outside. So now I have something that looks like 3, and it's read either 3 on the square root of 8 or 3 times the square root of 8. You'll hear me say both intermittently. It doesn't really matter what you use. Now, but this one is still not in simplest form because I can write that as factors that I can take the square root of. So this would be like 4 times 2. Okay, so now the square root of 4 is 2, so it goes out here, and then it would multiply times what's already out there. So 2 times 3 is 6, so that the square root of 72 in simplest form is 6 square root of 2, or 6 times the square root of 2. Now, this is important because when we start looking at the Pythagorean Theorem, we've got to be able to simplify square roots. Alright, so let's say that we have a right triangle, and again, the Pythagorean Theorem only works when you know you have a right triangle, which means the box is in the corner. Okay? And let's say that this side is 3, this side is 4, and I want to know what this side is. Okay, C is always the side opposite the hypotenuse. It doesn't matter which of these is A and which is B, that they form the legs of the right triangle, of the right angle rather. So that I'm going to square these and add them together. So A squared plus B squared equals C squared. The hypotenuse is always the side opposite the right angle. So then I have 4 squared plus 3 squared equals C squared. So 4 squared is 16 plus 3 squared is 9 equals C squared. So this is telling me that when I add 16 and 9, I get 25. Now, 25 is not my answer. That's what C squared is. So I have to figure out what C is. So I have to take the square root of both sides, because that's how I get a C. Square root of C squared would be C. So the square root of 25 is 5. Now, we also really didn't go back over the fact that when I take the square root here, it actually could be plus or minus 1. For example, -1 times -1 equals +1. So the square root of 1 could be a +1, or it could be a -1, either one. But what you need to remember is when you're talking about measurement, you don't talk about negative numbers. So when we're using the Pythagorean Theorem, the lengths of the sides are always going to be positive. Now, you can think about this as an application problem where you have a building over here, and I want to know how tall the building is. And I have a ladder that's extended out 40 feet, and it's propped up 3 feet away from the base of the building. So I want to know how tall this is, and know the building and the building and the ground make a right angle. So this is like an application then of the Pythagorean Theorem. So A squared plus B squared equals C squared. But in this case, I know C, so I could write it as C squared minus A squared equals B squared. Okay? So let's make this A. So we really have 40 squared minus 3 squared equals B squared. So 40 squared would be 4 times 4 is 1600 minus 9 equals B squared. So when I subtract 1600 minus 9, I get 1591 equals B squared. Now guess what? I don't think we can take the square root of that, but let's check. Okay, I hit the square root button, which is found right here on the X squared key. So it's a blue key. So I'm going to hit second X squared, and it's going to give me the little square root symbol. And I want the square root of 1591, and it's not exact. Okay? So for a problem that looks like this, if it says exact, then B would equal the square root of 1591. Now, let's think of the tricks that we know. 9, 10, 11, 16 won't divide by 3. It might divide by things that end in 1, sometimes divide by 1, 13, 17, 23, 27. But in all likelihood, when we have a number that's that large, it's probably going to say, give me an approximation. So when we give it approximation, we've got 39.887. And if it's rounded to the nearest tenth, that would be 39.9. And if it's in feet, then the building would be 39.9 feet tall. So that's an application of the Pythagorean theorem.